Hello, everyone, and welcome to the first episode of Data Centers and System Studies podcast, the podcast where we bring clarity, insight, and expert voices into the most important conversations shaping the future of energy system, renewable integration, and large-scale infrastructure. My name is Sam Maliki, your host for today's episode, and today we are focusing on the topic that's getting a lot of attention globally, and particularly in Texas, the unprecedented growth in demand for large load in ERCOT system. From data centers to industrial facilities, we're seeing a wave of projects looking to interconnect to the grid, and this is raising challenges and opportunities around interconnection, reliability, grid flexibility, and industry collaboration. To walk us through how ERCOT is managing this shift, I'm honored to be joined by Eric Meier, who plays a key role within ERCOT planning and interconnection team. Eric, thank you so much for being here.
Thank you, Sam. Thanks for the invite. My name is Eric Meier. I'm the supervisor of the ERCOT Planning Modeling team. We are the Texas grid operator for 90% of Texas. We oversee transmission planning functions and market functions as well. In Texas, we have a deregulated energy market where generation is unbundled from transmission for the vast majority of companies, and retailers are free to compete with each other to drive new market solutions and benefits for all consumers. On the planning modeling team here, we are looking at long-term transmission planning models. We also do 2 months away to 7+ years, looking at generation expansion, load expansion, seeing what's being submitted to ERCOT and how do we integrate those. Also been looking at the efforts from various industry task force like NERC's, the Large Load Task Force, E6 Large Load Task Force, and participating on a number of those efforts for the white papers and reliability guidelines that are underway.
Fantastic. I think our introduction was from LinkedIn. Your LinkedIn posts are great. Your participation in all these activities are great. And I'm sure that there's a lot of things happening. As you said, there are a lot of working groups and a lot of efforts that I think the industry really appreciate this. And these are really needed for what's happening today in terms of the large amount of loads that they are going to interconnect. So to set the stage for this conversation, ERCOT is seeing significant load growth and demand on the system from various resources, and much of it is coming from the large loads, including very unique type of large load. So for that, the first question that I have would be, what is ERCOT load projection forecast, including large loads? And what type of loads in ERCOT seeing that they want to connect to the grid?
Yeah, that's a good question. I'm going to state this is July 2025. The numbers are probably going to change as soon as in the next month. So just to put a timestamp on what we're looking at. We have essentially 2 buckets. We have the large loads and the large load interconnection queue, and these are closer to the operational time frame, and we have what's called substantiated loads. These are loads that they can have a contract, they can be designated by a letter from the officer of a transmission or distribution company attesting that this load is going to come. We've had discussions with them, or from a third-party load forecast that's been submitted, reviewed, and vetted. So when we specifically look at long-term load forecasts put together by our load forecasting team, they're looking all the way out to 2032 and beyond. So in ERCOT's most recent long-term load forecast, we've received letters of intent from the transmission companies, contracts, and third-party forecast that summed up to 218 gigawatts. Now, ERCOT's been interconnecting these large loads for a couple of years now. So when we see that number, it's a very high number and definitely takes a lot of review to make sure that's true. ERCOT conducted a review of those numbers, and we submitted a modified or adjusted ERCOT load forecast, which brought us down to 148 gigawatts for around 2032. And this is considering factors like how long does it take for these loads to actually be built. Somebody may say I'm ready to energize in a couple months, but independent discount factor. So they're looking at how many loads have energized in the past, what are the time delays between the amount that said they plan to be. If I planned 100 megawatts by this year, but I'm only at 50, we took statistics with those numbers, applied them, and then came up with this new 148 gigawatt number. So that's ERCOT's best estimate. As you know, We do a survey every year to get newer numbers from the transmission companies. And then there's constant growth in the load interconnection queue. So between one month to the other, there may be tens of thousands of new megawatts in the queue. And it's really rapid.
Exactly. So in terms of the type of the load, are you seeing more? Is it data centers load? Is it other types of loads?
Yeah, we got quite a few. So we have data centers, that's by far the biggest category. I want to say it's about 25,000 megawatts in the adjusted load forecast for 2032. After that, we're closely followed by cryptocurrency mining, hydrogen production, and other electrofuel production. And then you have electrification and manufacturing load as well. Really, the biggest category is the other data centers.
So how does ERCOT manage how large loads gets connected to the grid? And what is the process for large load?
We'll preface this is July 2025. This process is going to be in flux, especially with the closure of the legislative session and as we're evaluating the rules put in place from the legislature following direction from the commission. The general high-level flow chart is several years ago, ERCOT issued an interim market notice saying there's a lot of new loads coming. They're trying to connect in 6 months. That's posing a risk to the stability of the grid. At that time, ERCOT put in an interim process to say any new load connecting to the grid needs to get reviewed. It didn't say much more than that, other than it needs to be reviewed by ERCOT and the transmission companies. And it defined that as any load 75 megawatts and above. Carrying forward to 2025, ERCOT, the Board of Directors, and the Public Utility Commission have approved our Nodal Protocol Revision Request 1234 and Planning Guide Revision Request 115. So these substantially overhaul the load interconnection process in Texas, following that interim market notice. So now, if you want to connect to Texas, and we're talking about loads that are specifically in the large load interconnection, for those that are further out, substantiated with an officer letter or one of their third-party forecasts, those may not be in the queue yet. But if you are in the queue, you're going to submit an application that's saying, hey, I want to connect to the grid at point A, B, C. Or actually, you'll submit it to the transmission company. And the transmission company will come and say, here's the information. So the transmission company is the one that typically interfaces with the customer at that level. And they still are in a lot of cases here. So we'll get notified that there's a request to interconnect. Once we get some basic information, we can begin the study process and analyze, hey, are you going to hinder the reliability of the grid in the steady state domain, in the short circuit domain, in the dynamic domain, and so forth? Are you going to pose stability issues or overload a transmission line? We'll go through those standard reviews, and then we'll say, hey, you'll get a number if you're approved to energize. Now, the number you get may not be the full amount that you want. And you may also not be requesting the full amount right off the bat, right? It may take you a year to start building infrastructure, then another 6 months to get the next delivery of equipment at your site. You'll submit that load energization plan to ERCOT, which we'll consider in that review. ERCOT will then give you an approval to energize and an amount of how much we approve. You could get zero, your full capacity, or somewhere in between. It depends on the local conditions there. Once that happens, there's a commissioning checklist. As we get closer to real time, you will get included in ERCOT's operations models. We'll set up telemetry, go through the commissioning checklist with the control room and the load integration team, and they will manage that and bring you online. Once you energize, you become a normal load operating in the operations domain.
Fantastic. So once you were explaining this, a question come to my mind, or maybe for the audience clarity, you mentioned the transmission provider. So it's ERCOT, and also we have transmission provider within ERCOT, right? Maybe can you just elaborate on that, how the mechanism work here?
Good. Yes. So in ERCOT, we have both transmission companies, what we call transmission service providers. They are transmission operators, typically are transmission owners. Now, so ERCOT did not own infrastructure other than our buildings, flight control for the grid. We're managing the flow of power across the system and the scheduling of power plants, but we don't own these power plants. We don't own these wires. So transmission companies and generation companies submit all the data to ERCOT that we need to operate the grid. And then ERCOT uses that data in real time to say, hey, it's every 5 minutes, is the grid secure with state estimation and contingency analysis? So we're looking at all that, and the TSPs are the ones sending us the real-time telemetry data. They're the ones sending us the actual data on infrastructure in the field. I don't know what the parameters on the power line in the field are or of the load unless they tell me. And then we can put that into the ERCOT model. So the transmission company is the one that's actually building the physical infrastructure, while ERCOT is coming in and saying, here's your facility. Are you a risk to the system as a whole? Each transmission company focuses on their single transmission system, but the ERCOT system itself is a combination of 20 plus different companies, transmission companies, each of them all operating their own transmission system. So if you're right on the border of your system, you may impact somebody else, which is what we're screening for in bigger system-wide issues.
The way that I look at it is basically there is transmission provider TSPs and ERCOT, which they both need to satisfy what you are connected to the system and operate reliably and in a stable manner. All right, so let's bring up one of the key questions that my clients ask me, and it's becoming a hot topic today. It's a load flexibility and co-location. The question is, can loads be flexible in ERCOT? And is there any value to ERCOT and or the load?
Yeah, so we'll step back in time a little bit. If we look back 10 or 20 years, when we were looking at the transmission planning process, we would assume that loads were, constant for the most part. There may be some loads that follow cycles. Your residential load is going to go up in the evening when people are home, probably down in the day when folks are not home. Then you have your manufacturing industrial load that is pretty constant throughout the day. We typically didn't need to worry about loads being flexible and suddenly changing their demand because they just didn't have the technology or the need to. Now, today, with a lot of these computer-based load, our electronic loads, they can shut off in an instant and ramp down from full capacity to 0% in seconds. And some of the work that's been documented by the NOOC Large Load Task Force in the first white paper, which is going for comments and review at the RSTC at their next meeting, there's some great examples in there of a load going 400 megawatts in about 20 seconds. Which is just astounding compared to the past. That's not normal grid operations. So, question becomes, is there a benefit to that type of behavior? And is there a benefit to the load? From the system operator perspective, if we don't know about those types of movement on the loads, or if we don't have that baked into our models and our assumptions, if a lot of folks were to do that all at once, that could become a bit risky. There's only a certain amount of operating reserve that you procure for balancing at a given time. Power plants may be offline, or may not be able to respond fast enough. So if you get a really large amount of load moving in an uncoordinated manner, then we may have some issues. And keyword there is uncoordinated. In the ERCOT region, we have methods for coordination that offer benefit to the load. So the load, ERCOT runs programs for load resources, both controllable load resources and non-controllable load resources. Now, the non-controllable one is still somewhat controllable, even though that's in the name. It's more a bit on how they respond and are dispatched by ERCOT. But in both those cases, they can bid their load into this system, into the market, and get paid to turn off if necessary. So there's some benefit to the load where there's really high pricing. That's generally during times of system stress that we need the capacity and we need to free up room on the system. Your load could be flexible and they could ramp down and make that a resource available to ERCOT and it could benefit to yourself in that manner. So there are benefits to the load if they do that. There are benefits to ERCOT, but it's really helpful to us if it's managed and coordinated. Obviously, there's always going to be movement of the load, especially if we look at AI training. There's got to be some variability in there, but it also depends on your application. Because for a lot of these pieces of equipment, if your load's rapidly fluctuating, that's going to damage you. That may damage your equipment, that may wear it out faster. So it may not be in anybody's best interest for certain categories of load to be very flexible, right? There's probably mitigations and solutions that we want to think about there on how to offer more control. Maybe it doesn't have to be a control of the load itself, but could be a energy storage resource on site.
That's really interesting. The way that I look at it is they are fast and can behave extremely fast, but if it's not coordinated, it could be troublesome for the network. If we can manage it and basically tell them when reduce your power demand or increase it, then they can actually be l- like an asset for the network to help the system reliability and stability, right?
That's correct. They can, if it's done in a coordinated manner, they can definitely help us manage the system and optimize it in an even better way.
Perfect. And you mentioned that type of performance expectation to ramp down the power or increase the power can be done through a co-location. So that brings me to another question. Is it possible to co-locate load in ERCOT system?
It is possible to co-locate load with ERCOT. Part of that is, you know, now co-location is changed a little bit with Senate Bill 6 that was passed by the Texas legislature. The commission and ERCOT have not finalized all the rules there. It'd be a bit premature to say, hey, here's what it's going to look like once it all finishes. But co-location is possible. Traditionally, over the decades, there have been a number of various units in ERCOT, and those were traditional industrial processes where they're running a generator on site and they're using the steam to drive some sort of manufacturing process, chemical process, or other industrial process. Today, it's a little different where the load is just consuming energy straight from the generator. It's not a part of a manufacturing system. That's provoked some thought on how to change that, if any changes are needed, and how we handle co-location with those types of loads versus an industrial system. You can imagine if you have a manufacturing process, industrial system where the load is being fed steam, if you were to rapidly stop it or do something, that could result in damage to the plant or to the life and safety of folks. But if all I'm doing is running a computer, right, there may be critical services running on those computers, of course, but it doesn't quite have the same level of processes and industrial processes running back there. So there's some thoughts on maybe do we need to address that differently, which is, what Senate Bill 6 is taking a look at, what the commission and ERCOT are continuing to address. So if the load co-locates, it's going to partly depend on the setup to, I guess it's a bit more of a generic answer, right? But one effect is you're effectively removing power, assuming it's an existing generator. The system was designed for the generator to output. This is what was expected. Now we're taking that power source away. One of the biggest ones would be, are you able to still provide reactive support? So the generator is not only providing real power, it's also providing reactive power into the system to support it. If the load now is consuming that reactive power, we may see some differences in the voltages in that area, and that may be a challenge. The generator is designed to trip from the grid, and it has protection systems to protect it. But if there's a load right there, the protection system may need to be reconsidered and redesigned from the transmission company's perspective and the generator's perspective. If the load can somehow induce oscillations on the grid, subsynchronous oscillations, if it's right next to a generator, it may damage that generator. So we got to think about what are the control mechanisms and the feedback loops in there. And that's a real risk. ERCOT has seen load-induced oscillations that have been in the subsynchronous range before. There's been some great detail presented on at the ERCOT Large Load Task Force. It was presented at ESIG and across the industry.
You brought up a really good point in terms of the oscillations, or it's not always a steady state. It's not always we have a healthy system. Is there any other challenges you see here when they want to connect to the network?
Yes, there's numerous challenges the load poses. And a really good source on this is going to be NOAA's first white paper, which covers the risk of large load, risk and characteristics of large loads. And, I spent a lot of time helping draft that paper, and they'll cover especially some of the highest risk because they align with exactly what we're seeing in ERCOT as well. One of them is how do you handle your short-term forecasting? Your forecasting is going to drive energy procurement in real time, drive your procurement of energy and ancillary services. If you're wrong there and that load moves hundreds of megawatts in moments that you didn't anticipate, you have enough reserve to balance the system and ensure the stability of it. Now, another one is oscillations or stability, which we were talking about earlier. There's been several events of load-induced oscillations, one in ERCOT, one in Dominion, and there's been others across the United States and Europe as well. So, there's been events where data centers have caused oscillations that have needed mitigations. So we have the traditional stability concerns, and then also in there we have concerns, especially voltage drive too. So it's been documented in ERCOT, in Dominion, and in Ireland, events where there was a fault on the transmission grid. The transmission grid responded as it was expected to, but these loads tripped off. And in ERCOT, we've seen over a dozen plus events in the last year where hundreds of megawatts have unexpectedly left the grid that nobody expected, nobody planned for. It didn't show up in any simulations. And part of that, is, okay, how do we address that issue? So ERCOT has, in the middle of working on how do we address these large electronic load ride-through issues. And if you follow ERCOT's large load working group, you'll see some of these solutions that are being considered. So eventually that's probably going to result in a change to that interconnection process that we talked about earlier. There's going to need to be thought by the large loads on how they handle these issues. We can briefly go into the ones in ERCOT, Dominion, Ireland as well. But there's other issues that we're seeing too. We're also seeing issues, automatic protection schemes. So if those loads trip, the grid has a last line defense called under frequency load shed, or UFLS scheme. If we lose generation and the frequency begins to decline, these relay systems will automatically disconnect load from the grid. We also have systems for over frequency. So if too much load leaves the grid at once, all of a sudden your frequency will rise. And if it hits a magic number, depending on your area, around 60.4 hertz, these generators will disconnect themselves to protect the equipment. At that point, we lose the generation and load balance. And the number one job of grid operators is to ensure generation is balanced with load. If it's not in balance, that could lead to a bad time on the system, to say the least. We saw a recent blackout in Spain where these under frequency load shed schemes didn't activate in a right manner. Now, that had nothing to do, as far as we can tell, with the load side, although the event analysis and investigation is still underway. But it's a good indicator of what can happen if you don't make sure your protection schemes are up to date. If we see a large amount of load trip that impacts those UFLS schemes, we may not shed enough load. Right now, you have to evaluate those every 5 years per standards. That's something to consider as well. We're really taking a look at it. What these loads are connecting today, what are the automatic defense systems of the grid? Those need to work no matter what.
I had a discussion with one of the data centers operator, and I raised this point back in the time. What about fault right through? And they said that it's perfectly fine. Once anything happened, we switch to the UPS. So the load stays online, right? In terms of the perspective of the data center operator, that's the fault true. They are surviving the load. But what is missing here, I think, they are not connected to the grid anymore.
Correct. And, from the loads perspective, they're right. From the traditional, what they've always thought is, my load's online, but I'm continuing to work because their primary business is running those servers or running their process. As long as the process is working, they've done their job. For us, we're trying to ensure grid reliability. And in the past, load was smaller, much smaller, right? We didn't have gigawatt-sized load. The loss of any one load didn't really affect the system that much. it could be handled in the course of normal business. But now where we have loads that are hundreds of megawatts to gigawatts that could drop off, that's a very different story. And so from our perspective, that immediate loss and cessation of load is what poses a risk. So each person is sort of always historically been focused on, their view. For us, it's on the grid side. For the load, it's focused on their side. We're really at a point where we both need to talk more. Both industries need to engage, build those relationships, and understand the challenges both of them face to figure out how can we collaborate to solve these problems. Because on the other hand, while it may be looking for the load, if the grid were to go down, they're not going to have a grid to come back to customers to serve. So that's going to be a problem for them, which nobody wants that problem. We want to make sure they have a grid to come back to.
Absolutely. In terms of the industrial collaboration, I think you raised a really good point. But before I get there, I just want to re-emphasize or ask you to elaborate on the importance of the load and generation balancing. Like what does exactly mean that I need to have 60 hertz system and a little bit movements here and there, that's maybe a trouble.
A little bit of movement's okay. So our system designed for 60 hertz. In Europe, it's 50 hertz. Other parts of the world, it depends on your history and how your system was built. But in the United States and North America, all that infrastructure and all electrical devices expect 60 hertz. So if the frequency changes and you're running a motor, the performance of your motor may degrade, right? It may speed up, it may slow down, depending on how the frequency is moving. And that could damage your end process, that could damage your motor. So a lot of folks will have devices to protect their equipment, right? If I plug my phone into the wall to charge it, that device is looking for a certain range of power. If I supply too much power, I'm going to burn it out. So our equipment expects certain parameters on our electricity: frequency, voltage, current. When we have this demand balance, load and demand balance, that means every megawatt of load plus losses is met by a megawatt of generation. If I have too much generation, my frequency is going to go up. If I have too little generation, my frequency is going to go down. There are automated systems that will detect if a frequency goes too high or too low and start removing equipment to protect itself. Now, the problem is if too much of this happens at once, the frequency goes too low, we cannot arrest the frequency decline or overshoot. So it essentially starts to compound and cascade. First one device trips, then another device trips. And if too many devices trip, we lose control of the system and we can't ensure that balance. And then we have what's called a blackout. At that point, there's no more lights on the system and we have to begin emergency procedures to restore the system.
And it's a time-taking process. So my takeaway here is that as a load customer, you need to think of a system as a whole. It's not just you to be provided. And if you need the power, you need to work in and satisfy rules and regulations to make sure that everyone gets the power. So the question for you, are there any industry efforts underway to address these reliability challenges? How should load owners engage with these efforts and grid operators?
Yeah, there's quite a few efforts underway. Some of the big prominent ones are the NOC, Large Load Task Force. They are working on assessing the risk and characteristics of the large loads, and they're also doing an analysis of the gaps in standards and utility engineering practices based on those risks. Finally, they're going to be writing reliability guidelines, which are recommendations on how to handle some of the risks that these large loads pose to the system. Now, they can't recommend specific technological solutions, but they can recommend changes to the interconnection processes, to analysis, event analysis, coordination, and processes like those. So That's one priority. And eventually that will likely culminate in standard authorization requests at the level where folks will modify standards to figure out what changes we need to reliably support the grid. Odds are there's going to be some changes coming from this process, and then we're currently working under a liability deadline. There's also efforts by the Energy Systems Integration Group to take a work with load developers and load owners and folks on the grid side to look at market issues, planning issues, interconnection issues, and performance issues with these large loads. We have ERCOT, Large Load Working Group, which is focused on issues in the ERCOT region. Definitely loads are participating there, transmission companies, and we're looking at issues like large electronic load right through. We're looking at oscillations and reviewing protocol changes, planning guide changes, and operating guide changes related to these large loads. The potential need for right-through curves on these loads, that's the venue where they're looking at that in the ERCOT region. There's also other industry efforts. EPRI is running their DC Flex initiative, which some exciting news came out recently with Scale, I believe it was. They demonstrated some data center flexibility in the Arizona region. So, the EPRI's initiative is working with hardware providers and data center operators to actually trial technology and trial, new research and survey technology test beds for loads to become more of a grid asset. There's also, a report coming from IEEE that was published. There's potential IEEE task forces that are looking at being formed, same in the C-grade domain, the data center coalition serving as a resource. And so one of the challenges is there's so many efforts going on. How do you keep track of them all and know which ones to engage in? And that's been a challenge for everybody involved.
I'm trying to keep up attending working groups, and my schedule is full of large load task force. They all have the same kind of name, LLTF, and I'm like, which one is this? But I try to attend. I really encourage everyone to attend as much as they can because it's ever changing, and everyone is trying to understand how to manage these large scale or hyperscale loads. Is invaluable to attend these meetings. So, Eric, I think we are at the time. First of all, I want to thank you. It was a great discussion. Thanks for sharing your insight. I think this conversation has been incredibly valuable, especially for companies and communities trying to navigate this complex and fast changing environment. Before we end the session, I want to just ask if I missed anything or if you want to share anything beyond what we discussed.
I think the last point I'll make, Sam, is to sort of reiterate what you just said, which is we really need load owners and developers to participate in these industry efforts and engage with grid operators. There's always challenges where designs are confidential, customer information is confidential, but we need to figure out ways to work through that. Otherwise, we're going to be forced to make assumptions on how these loads operate, but we also can't let one party jeopardize the system. So please, if you are a load owner and you're trying to get involved, there's a lot of ways. Sometimes you just need to get in touch with somebody and they can help point you out.
Absolutely. So I think the key takeaway from here would be the participation from all parties, developers, OEMs, whoever has some information of the past, how they've been operated and everything on that, to basically help everyone have a reliable and stable grid in the future.